Hello everyone, this is DEEPAK Joshi, and today we are going to solve another problem statement from LeetCode, that is path sum 112 is the problem statement name. So here we have given a root of a binary tree and a target sum. And what we need to do is we need to figure out whether from the given binary tree we have a path from root to the leaf node that sum up to target sum. What does that mean? Like here we have this example in which 5, 4, 11, 2, 7, 8, 13, 4, 1 are given, and the input root is given and the target sum is 22. Okay, and we need to figure out whether from the given thing, like I'll just do minus so that my, yeah, from the given thing we need to figure out whether the path from the root node to the leaf node will comprise target sum or not. Let's check. Let's start with 5, 4, 11, 7. So that will be 9, 20, 27. No, our target is 22. Let's do 5, 4, 11, 2. So it will be 9, 20, 22. So seems like the colored path is the answer. And yes, from root node to the leaf node we were able to comprise the sum 22. We don't want whether we will be able to calculate the sum from the nodes, but we want to trace from the leaf node, from the leaf node or to the root node, or from the root node to the leaf node. Like it should be a whole trajectory from starting to end. Okay, and this pretty case is simple. This case is pretty simple, I would say, because 1, 2, and 3, and the target sum is 5. So individually it is possible from the node we can calculate that from 2 and 3 because the sum is 5, but we need to trace from the root node to the leaf node. So 1 plus 2 is not 5, 1 plus 3 is also not 5, so not possible. Okay, this seems nice. Now how we will approach this, it's pretty basic, I would say, because if we have done basic DFS, we can do that, the depth first search, and we can start from the root node and go in left and right, and then do check the values whether we are able to calculate the sum. For target sum, I'll do target sum minus the value, so that in that case the last node, my approach will be 22 minus 5, then the which is 17 minus 4, the um which is what, 13 minus 11, and then which is 2 minus 2. So till the root node it will be 0. If that will be the case, I'll be returning true, else I'll be returning false. Yeah, that seems doable. Okay, now so what I was saying if there is a case when, let's compute the case when we are at 2. Okay, so in that case our roots left uh, and I would say roots left is equals to null, and roots right is also equals to null. That means the left and right both does not exist. So in that case, what we need to check is, I'll simply return, not check, I can return directly the target sum minus our root's current value. If it is equal to 0, in that case we'll just return true. If it is not, then we'll return false. That's nice. And in any general case, what we will be doing is we'll be doing target sum will be equal to uh, yeah, will be equal to target sum minus root's current value. Okay, that makes sense. Probably we could have done it like this. Yeah, this is also possible. So this is the general trend, and if we are on the leaf node, then we'll check whether the final value of the target sum becomes 0 or not. If that is the case, that means we have traced everything, else not. Okay, so we have done that, and now we'll utilize recursion. We'll check the same for the left row node, root left, I would say, and the target sum, and one of them will be true. If the whichever is true, just return it. So I'll do an or with it, and as path sum roots right target sum. Um, yeah, this seems pretty simple, right? But there is a edge case. We have handled these cases, but we need to handle the case, let's say, where the recursion happens and the left node, like this is the case where both left and right node is not available. But let's say the left node is available but right is not. So this is not the going to the code is not going to be inside if. We'll go over here and then call a root left. So for 4 left does exist, but for 4 right doesn't exist. In that case, what it will do, it will try to do null left, which we don't want. So we'll have a base case over here. If that is not a base case, I would say edge case, that if root doesn't exist, return false. Yeah, I think we are pretty it. Let's try to, I think I am a lot zoomed. We could have done it like that so that the code is pretty, yeah. Seems like the test cases are running fine. I'll just hit submit and let's see if the this works. Yeah, seems like our code beats 100%. Again, I don't trust this. And yeah, let me know if you have any other problem statements. I'm happy to help you. Bye bye.